Greetings! The difficulty level of this video is moderate. Today we are going to examine wind power and more specifically the technological and economic effects of wind power. Wind power is the sister technology to solar power. The two are similar in some ways but also complete opposites in others, and both fit under the broader category of green electricity, and as a result both are very politicized and distorted by a lot of government intervention. Nonetheless, there is considerable technological advancement in the ability to generate electricity from the wind itself, and that's what we'll be looking at today. So in this Wikipedia article, I scroll down to the first and most important chart, which is global wind power. As of 2021, wind power generates almost 6% of the world's electricity. That is not a small number. By 2007 or 2008, it was only 1% of the world's electricity, but now 6%. It is not growing as quickly as photovoltaic electricity, solar power, but it is growing. The reason solar power is the faster advancing technology is because solar energy is closer to the first principles of technological progress. There is exponential progress in that. In wind power, there are fewer factors of technological progress. The design of wind turbines has improved somewhat to capture more of the wind. The material of wind turbines has also improved to make them lighter, and as more windmills get erected, there is volume, so the cost of creating subsequent windmills goes down, but these are ultimately relatively weak factors relative to the progress in photovoltaic technology, which is closer to a semiconductor and therefore a more exponential technology. Nonetheless, the amount of wind power, as you can see from this chart, has in fact tripled in the last 9 or 10 years and is certainly about 100x what it was 25 years ago. So wind power does generate 6% of the world's electricity once again. Between solar and wind, these two combined now generate about 10% of the world's electricity, and therefore we are very close to the point where these two in tandem become a very significant portion of the entire world's energy complex, especially since we are simultaneously experiencing a disruption where gasoline-powered cars are being displaced by electrical vehicles, and the electricity that these vehicles use is in fact being generated by solar and wind power to a greater and greater extent. So there are two simultaneous disruptions. While solar will certainly become a larger percentage than wind power in the near future, the fact that wind power is in fact 6% and could plateau at 7 or 8%, that's still a relatively high plateau as a percentage of total world electricity, particularly when you consider the displacement of oil consumption with electricity to some degree from vehicles. This chart corresponds to the growth rate of wind power because this is the cost of wind power per kilowatt hour, 1983 to 2017, and you see this downward trend indicating exponential progress and therefore corresponding to the high growth rate of wind power over the same period that we saw in the previous chart. Again, this is an exponential technology. It is not as exponential as photovoltaic power, solar power, but is still very respectable in its own right and non-overlapping because the land that's most suitable for wind power is absolutely not the same land that's suitable for solar power, so these two are never in competition with each other, nor are they in competition even in the same countries for the most part. Very few countries are large enough to even have a significant amount of both, but almost all countries could have at least one out of the two. Now, on the negative side, wind power is heavily subsidized across the world, and therefore this growth is in some cases artificial. That does not mean it will be reversed, because when a country can subsidize its own wind power rather than rely on oil that it imports from other countries, that is one of the rare instances where a subsidy might still be a net positive for the total economy. We've spoken about on other channels how bad it is for a country to have a trade deficit, and that certainly applies to trimming oil imports in favor of any domestic energy source, even if that source is subsidized. Now, the other dimension to look at is the amount of wind intensity in various parts of the world. This map tells you what mean wind speed is in various parts of the world. Now, unlike solar, wind is actually a 24-hour technology, where solar power is obviously only during the daytime. At the same time, wind is intermittent and it works a lot better in very windy parts of the world, which you can see are usually at high latitudes and much less so near the equator. Now, this can be particularly convenient because the best places for wind turbines are not where a lot of people live. In fact, they are in frigid areas that will never be heavy in human inhabitation. Now, this is another factor that is favorable for both these technologies, solar and wind. Both actually make use of land that is not only unsuitable for human habitation, solar because it's too hot and too sunny, and wind because it's too cold and too windy, and therefore monetizes and harnesses what used to be a dead natural resource, effectively creating a new natural resource for everyone out of thin air, in this case literally. High wind was something that was of very little value, particularly in polar regions, but now you can generate billions upon billions of dollars of electricity from it. That is very good. And you may say, what is the purpose of generating electricity in a place that's too cold for people to live? Well, electricity demand is not always physically located near population centers. You may be aware of how data centers are becoming a larger and larger portion of world electricity consumption. And while the engineering efficiency of data center hardware continues to improve, it is still rising as a percentage of total world electricity consumption. It's about 5 or 6% of all electricity consumption worldwide today. And data centers do not need to necessarily be near human population centers. The data centers that are used for high frequency trading do have to be in places like New York City, simply because the trading is on an order of microseconds or nanoseconds. But data centers of any other purpose can be located near where the electricity is generated and does not have to be near a city. It is far cheaper to transmit data over a long distance than to transmit energy over a long distance, and therefore locating data centers in these cold regions where the power is being generated and where cooling costs will be lower. Remember, a data center generates a lot of heat, and the hardware has to be cooled. If the data center is located in a place that's already very cold, then those costs are lower as well. So those are elements of the multi-pronged technological disruption that is occurring, and of which wind power is a very important component. Now, looking at a country-by-country basis, the proportion of wind power usage relative to other forms of electricity by country is not exactly what you would expect from this map. The share of energy from wind power is concentrated in Europe for sure, and that's not surprising based on the previous map, but it is very high in Brazil for some reason, despite the wind intensity in Brazil not being very high, and it is not very high in Russia or even Canada, both of which have a tremendous amount of frigid land where very few people live that have a great deal of high-speed wind. So again, this is because of subsidy distortion. Some countries are very keen on subsidizing wind power and others are not, and that leads to growth distortions by country. There's some European countries that derive 30 to 40% of their electricity from wind power. So that is the basic primer on wind power. I will do update videos each year as the annual generation metrics get updated and as the percentage of all electricity generated by wind power gradually increases and gets closer to saturation. But I hope you found this introductory video useful. If you like this type of content, I encourage you to subscribe to this channel, and thank you very much for watching.